So now we are starting parasympathetic nervous system. So first of all, we will see what we are going to study in parasympathetic nervous system. So first of all, we are going to study synthesis of acetylcholine. After that, we will see cholinergic receptors. After that, we will see parasympathomimic drugs. And at last, we will see parasympatholytic drugs. So now we will start with synthesis of acetylcholine. So now we will start with synthesis of acetylcholine. As we know, acetylcholine is a neurotransmitter. So that means it is produced inside neuron. It is our neural cytoplasm. So now we need to see what are the raw materials which we use for acetylcholine. So here we have choline. We take this from outside, we take this from circulating environment. Like it comes inside. So here already we have acetyl CoA. So it leads to acetylcholine. So once acetylcholine is formed, it is then stored in vesicle. So it remains in the vesicle until the neuron is not stimulated. Once the neuron is stimulated, it leads to exocytosis of acetylcholine. So once it's released, then it starts acting on receptors. Like in case of parasympathetic nervous system, we have two types of receptors. One we have M type, and then we have N type. So it starts stimulating these two receptors. One thing you need to remember is that the availability of acetylcholine in the synapses is directly proportional to parasympathetic activity. If we have more acetylcholine in the synapses, we have more parasympathetic activity. If we have less availability of acetylcholine in the synapses, we have less parasympathetic activity. So now we don't need parasympathetic activity forever. Sometimes we need to decrease parasympathetic activity, and sometimes we need to increase parasympathetic activity. Like if we have a patient with bradycardia, we need to decrease parasympathetic activity and we need to increase sympathetic activity. So here we will discuss some drugs that we can use so that we can inhibit or we can decrease parasympathetic activity. So the first drug which we use is hemicoline. So hemicoline, it inhibits uptake of choline by the neural cytoplasm or by the neuron. So which means we have less availability of acetylcholine. When we have less availability of acetylcholine, we can say we have decreased parasympathetic activity. So another drug we have vesamicol. Vesamicol, it inhibits uptake of acetylcholine by vesicle. When it inhibits uptake, it means we have less availability of acetylcholine. And when we have less availability of acetylcholine, we have less parasympathetic activity. Here we have another drug, that is botulinum toxic or toxin. So it inhibits exocytosis of acetylcholine in the synapses. So once again, when there will be no exocytosis, we have less availability of acetylcholine. When we have less availability of acetylcholine, we have less parasympathetic activity. So here we have last enzyme as acetylcholine esterase. Acetylcholine esterase, it inhibits acetylcholine. It metabolizes acetylcholine, so now it cannot work on receptors. Like it metabolizes it into acetate and choline. So we can use these four so that we can decrease parasympathetic activity. So finally we have acetylcholine, it starts stimulating receptors. So now we need to know what are the parasympathetic receptors, how they are subdivided and where they are present. So now we will study classification of cholinergic receptors. They are subdivided in two parts. One we have nicotinic and another we have muscarinic. One we have nicotinic and second one we have muscarinic. So nicotinic, it is further divided into two parts. One we have NN type, another we have NM type. So NN type is present in ganglia and adrenal medulla. So after that we have NM type. NM type is present in neuromuscular junction. So one thing we need to know about neuromuscular junction is that it requires optimum stimulation. If it is overstimulated, it can lead to weakness. If it is understimulated, it can lead to weakness. So we can study this in case of myasthenia gravis. Once we study myasthenia gravis, we will see how it works. So now we are going for muscarinic receptors. They are subdivided into 5 parts. We have M1, we have M2, we have M3, we have M4 and we have M5. So M1, it's present in gastric ganglia. And CNS. M2 is present in heart and CNS. So M3 is present in eye, GIT, bladder, bronchus, and glands. Also M3 is also present in CNS. So M4 CNS, M5 CNS. So this was all about cholinergic receptors. So now we will see the drugs which work on these receptors.